Okay, in this lecture, I want to talk a little bit about using MATLAB to take the Laplace transform. MATLAB is a very convenient way to take the Laplace transform. You have to have a couple of things in your MATLAB toolbox. The first thing that you have to have is you have to have the symbolic math toolbox. And so I've opened the help sim function so that you can look and see basically what this does is this defines a symbolic variable. And when you normally in MATLAB, when you have a variable like t, you need to set that up and assign it values. So we might say t is equal to some range from 0 to 100 seconds in increments of 1 millisecond. And so we set that up and we assign a value, a matrix value to t. The Laplace transform and the symbolic math toolbox work a little bit differently because in the symbolic math toolbox you have to actually define a symbol. So it's kind of easy to use the wrong tool. This one is pretty useful because it's a shortcut way to define symbolic variables. So you can actually say sims of t, and that will construct the symbolic variable. So for example, I can say sims t. And so now MATLAB knows that t is a symbol and not an assigned variable. So now what I can do is I can say something like Laplace of a function of time. So let's look at what the Laplace command does. So the Laplace transform takes the transform of a function f that has some default independent variable t. So you have two choices here. You can actually define the function within the Laplace command. So for example, right here, we've defined a symbol of t. And so we're basically taking the Laplace transform of t to the fifth. Here we have some other symbols that have been defined so that we can take the Laplace transform on variables, but the only one that you absolutely must define is t. So we have already defined our symbol t, and we can actually start because MATLAB is going to remember that t is a defined variable. So let's just look at the Laplace of t. So if I do that, basically MATLAB is going to tell me that the Laplace transform of t is 1 over s squared. I can look at the Laplace of cosine of t using double brackets here. And here we go. The answer is s over s squared plus 1. So in general, this is relatively easy to use. Let's look at the Laplace of t cosine of t. So here, basically, it's just normal MATLAB syntax. So the asterisk is the multiplication. And the only difficult thing is, for example, if you wanted to do the cosine of 3t, you have to remember to use the multiplication. You just can't put 3t, you have to put 3 times t. So if we do that, okay, so notice it doesn't like that. Expression or statement is incorrect. I appear to be missing a parentheses. Yes, that is what I mean. 3 parentheses on the end. So there we go. And here's your result. And as you can see, they can get relatively complicated. So taking the Laplace transform using MATLAB is a good thing. It's a great way to check your algebra or your math. to make sure you got your transform correctly done. Sometimes it comes out in kinds of awkward ways, so it's sometimes you have to be careful. Okay, well, let's look, for example, now at a different approach. Let's look at taking the inverse transform. We'll define S as a symbol. And let's look at inverse Laplace. So that would be the command iLaplace. And once again, we're going to have to be careful to get our syntax correct. So let's just, for the case of doing something interesting, let's go up here to this previous expression and let's take its inverse transform. So let me copy that expression here. Okay, so basically I'm taking the inverse transform of the previous example that I worked, so we can scroll back up here. Remember that was t cosine of 3t. So let's do that and see what comes out of the inverse Laplace transform. And there it is, t cosine of 3t. So, so basically this, this gives you a good workable expression and allows you to go back and forth. Now, sometimes when you take an inverse Laplace transform, you'll get a really weird expression, and as we work some examples later on, I can show you some of those. It's sometimes will return a function called Heaviside, which is the step function. It will sometimes return a function called Dirac. So you just sometimes when you get things, you might need to rearrange them into a form that is a form that you want. But taking the Laplace transform and the inverse transform becomes much easier when you use